Hi everybody, and welcome to this introduction to the insertion sort algorithm, a classic sorting algorithm in computer science. And whether you're a JavaScript programmer, a Java programmer, a PHP programmer, a Ruby programmer, or an R programmer, at some point in your programming life you will no doubt encounter insertion sort. So let's have a look at how it works. Insertion sort it operates on data structures, and here we have an example of a one-dimensional array of integers. Conceptually, an insertion sort algorithm breaks a data structure into two sections. The section on the left can be considered the sorted section, and the section on the right can be considered the unsorted section. And what we're going to do in the unsorted section is process each value step by step and try to determine where each of these values needs to be inserted into the sorted section. Okay, and we're going to have a look at how to do that today. As you can see, the unsorted section starts at the second element in the data structure. This is the unsorted section. It's always the same in insertion sort. Okay, so this is one of the rules. Start at the second element in the structure. And we're going to process each of these values as we sort the array. So the first line of our algorithm in this example is going to be this, because we know we're starting at index 1 and we're finishing at index 6, because we will be processing all of these values, no doubt. So a for loop is perfect for us to do that. Now, what insertion sort does is it goes into the sorted section and it compares every value in the sorted section with the value that we are currently processing in the unsorted section. So as we get started here, we're simply going to compare 11 with 7. And if the value in the sorted section is greater than the value that we are currently processing, then this value in the sorted section is going to move one place to the right. So let's see that happening if we run the algorithm. As you can see, the value 11 has moved one place to the right, because 11 is greater than 7, which is the value we are currently processing. That's the end of this particular loop, so the 7 is going to be placed in this element here. Now let's do another process before we turn our attention back to the algorithm. Oh, can you see that I has become 2? So our for loop is controlling that. I is now 2. Can you also see that the first index of the sorted section is always I minus 1. That's the starting point. This controlling variable here always starts at I minus 1. Now we can see the for loop forces I to increase in size as we go through the loop. I is 1 to 6. But in the sorted section, this index is getting smaller in size. In this example, the variable is currently 1, but the next time we go through the loop, it's going to go down to 0. So that's interesting. So let's look at what would happen if we process the current scenario. We're going to compare the value that we are currently processing in the unsorted section with every value in the sorted section. So let's start with 11. Is 11 greater than 10? Yes, it is. So 11 will be moved one space to the right. This will be now 11. This controlling variable is going to take us down to the next value that we need to look at, and Is 7 greater than 10? No, it's not. So this controlling variable will be sitting at index 0. This is not greater than 10, so our processing will stop, and this 10 will be pushed into index 1. So let's see that happening. 11 pushed to the right. The control variable for the sorted section has reached a condition where the value here is not greater than the value we're currently processing, so we stop, and my algorithm has determined that the insertion index is this value plus 1, because the insertion index is 1. Now let's try to insert 7. So I has become 3. Let's call this one J. J has become 2. So array 2 is greater than the value that we're currently processing. Oh, by the way, this is useful, isn't it? Do you remember that if the value that we're processing is greater than if the value in the sorted section is greater than the value that we're currently processing, we move it one place to the right. The danger is that we will overwrite the value that we are processing in the unsorted section. And if we overwrite it, we're not going to be able to compare it with other values in the sorted section. So we need to store that in a temp area, temp variable. That's the purpose of this. So 11 is greater than 7, true. So 11 will move over. 10 is greater than 7. True. So 10 will move one place to the right. 7 is greater than 7. Not true. Our processing stops. It doesn't need to continue. And we have found a new home for the value that we're currently processing. So let's break some of those ideas down into pseudocode. First of all, we're going to store the value that we're currently processing into a temporary variable. So if I is 3, we're going to store array 3, which is 7, into a temporary variable. That's what's happening here. We also need to figure out the index of the variable controlling the sorted section. And we know that that is equal to I minus 1. We now want to say, while this thing is greater than this thing, we're going to push this value one step to the right. Right? J is 2, so R, J plus 1, which is this one, R3, will be assigned the 11. So the 11 jumps over here. And then this control variable, which is processing the sorted section, decrements. And that is the end of our while loop. That's all that happens. Compare this with temp and move it to the right if it's bigger. Decrement J, compare this with temp and move it to the right if it's bigger. Well, that's still true. Decrement J and compare this with this temp and move it to the right if it's bigger. That's not true. So the while loop has stopped now. J is currently 0. J has reached 0 and the processing has stopped because this is no longer true. 7 is not greater than 7. So currently J is 0. So we can do this. j is 0, but this is going to be the place where we push our temp variable. Okay, so let's sort it and just see if that works. J is 0. That's the end of the processing. So the algorithm has determined that the insertion index for this value is 1, which is j plus 1. Now, if we were to process all of this, let's process it. I is now 4, j is 3. 11 is greater than, and temp is also 3, by the way. Notice we've taken the value we're currently processing, we've pushed it into temp. 11 is greater than 3. Yes. So 11 jumps over there. 10 is greater than 3. Yes. 10 jumps over there, and j decrements. 7 is greater than 3. Yes. 7 jumps over there, and j decrements. 7 is greater than 3. Yes. 7 jumps to the right, and j decrements. J decrements. Oh no! J is now -1. J is -1. So when we come back up to the while loop, r -1 is going to give us an out-of-bounds exception error, because in this situation we've gone outside the array. So we just need to put a little bit more logic here. We just need to say, okay, keep doing this while j is greater than or equal to 0. That will take care of our out-of-bounds exception error. And that is the algorithm for our classic sort, insertion sort.